So in this video, we're now going to take a look at the profiler. Profiler is really useful when you're wanting to debug a game and you're wanting to know more about what's going on behind the scenes and how the actual game is running. Okay, you can find the profiler under Window, Sequencing, Analysis rather, and Profiler. Okay, now you get a profiler or a profiler standalone. I'd recommend using the profiler at the moment. And if we click this, it comes up like this. Now it does look a little bit intimidating to begin with. What I'm going to do, I'm actually going to dock this down here. I'm going to bring this up like this. Bring this down so that I can see more of what's going on. By default, it should be ready to record. Okay, if that's not highlighted, just make sure you press that. I'm going to maybe mute the audio, but don't maximize on play at the moment. And I'm just going to press play. Okay, and then you'll start to see all sorts of business going on here. Okay, here we go. It's starting to show me exactly what's going on in terms of every frame. So as soon as I press pause, okay, it allows me then to analyze exactly what's going on. So if you take a look at the timeline at the bottom, this is actually showing me my main thread and my render thread. It's showing me what the actual processes are and what's happening. With any one of these, you can just click on these in order to get a little bit more detail. All right, and we'll come to a lot of these later. The different jobs that it's doing, you can review these, how long they're taking in terms of milliseconds, etc. So there's all sorts of things going on there. But what I want to focus on at the moment is the draw calls. Okay, so that'll actually be part of my rendering. So if I click on rendering, it's actually going to show me now. And it's actually saying draw calls 0. That's interesting. I wonder why it's saying that. Let me make sure, there we go. That's better. All right. I don't think I had nothing selected on the screen there, so you do have to select something. So at the moment I got 25 draw calls. So a lot of these objects are now being basically separated into draw calls. And where we say static batching, batch draw calls, we're on 0. Batching means that it takes a bunch of objects and sticks them all together in one group and it saves draw calls. Okay, it's rendering a total of 1.8 thousand triangles, 2.9 thousand vertices. That's what's in our scene. Set pass calls is 3, so in other words, how many separate elements are there? There's the ground, there's these, and there's the trees. Okay, what that means is basically any item with a separate material. Since all these items have the same material, because it's a texture atlas, they all come under that one set pass call. The trees are using a different material and the ground is using a different material. Okay, use textures, we only have 3. It's taking up a total of 106.8 megabytes in memory, or at least video RAM. Rendered textures at the moment, just 6 up to 34 megabytes. Okay, so it gives you loads of great information. What it also displays is a visual guide as to what's happening in terms of your rendering there. So you can see exactly how many milliseconds it's taken to render. What we can also see under our CPU is the time in which it's rendering. It's playing scripts. There aren't any scripts at the moment. Physics, animations, garbage collection, VSync. We switch VSync off, so that should be 0. Global illumination, UI, and others. So most of it at the moment is taken up with others and rendering. So you can actually switch some of these off. So if, for example, I switch all of these off, so I'm just left with rendering and others, and you can see there was no change. So all of those were nothing. If I switch others off, this is what's left on our rendering. Now the others, I'm not entirely sure what's covered in others, but rendering is our main concern at the moment. So we can see that it's relatively low. You can actually use your slider at the bottom to move out, and it's got these little caps on the end, so you can actually bring these in. Just make sure you're actually clicked on the item that you want to see. Alright, it only gives us that particular, that was when it actually started, that's when we paused it, so there's no other elements to see there. Okay, you also have memory as well. If I can see a spike in memory happening right there. Something's happened at that particular point in time, so you might want to click memory and find out exactly what's going on there. We get our different audio. For some reason we've got some sort of audio going on. Any kind of video devices, we've got no video rendering. Any kind of physics elements, we've got no physics in there at the moment other than a box collider. Physics 2D, networking messages if you're doing anything online, network operations, once again if it's online. UI is our user interface, any kind of 2D graphics that are on the screen. Well, we don't really have any of that at the moment, even though we're getting these very, very tiny spikes. And then global illumination. Wow, this is basically all of the lighting. Since we actually have a directional light in there at the moment, presumably most of this is coming from the way it's interacting with these objects. And then virtual texturing. Okay, so as part of our rendering then, we've got a draw call of 25. Let's remember that. What I now want to do is switch this off. I want to take all of these blue elements, so just hold shift and click on this one, and I want to drag them onto ground. So I'm going to parent them to the ground. Do the same with all of these, just hold shift, let's drag them all onto the ground. Okay, in this way we can then close down the ground, and that's all of these items parented. So now I can click on ground and I can now choose static. It basically means that these objects will not move. I'm going to say yeah, change the children. That changes all of the sub elements, that's all of those. Okay, and what it's done, it's basically ticked all of these items on. All of these items are basically meant to optimize the performance. If an object doesn't move, always mark it as static. Okay, because otherwise Unity is going to pay special attention to the object, thinking it's going to change position from frame to frame, and it never will. If it's static, it knows it's always going to be in place, so then it can do its optimization stuff. So wherever we've got these animators, we probably have it on all of them, so I'm just going to hold shift. Okay, when you get something like that, it basically means you can't select multiple different types. Just all these mobile tombs, I'm just going to right click on animation and choose remove component. Do the same with all of these, just right click, remove component, we don't need any animations. Trees, right click, remove component, and that first tree, right click, remove component. Mobile unlit, alright, that's great. Now on all of these items, at the moment we're going to leave the cast shadows and receive shadows on. Later we're going to switch those off. Alright, the reason why we're leaving them on at the moment is so that we can actually bake some lighting soon. Now that we've made all of these static, let's now do another profile. So I'll just drag this up, press play again, and it should start right back from the beginning. Here we go, and then press pause. Alright, so we've stopped. So now if I click anywhere and I click rendering, we've now got 4 draw calls. Okay, so massive saving. Static batching is now batch draw calls of 24. That's how many items we had before. It's now batched them all up, and it's only sending 4 commands from the CPU to the GPU. So that's going to instantly make your frames per second so much better, and it's going to be so much faster. Okay, notice also the triangles are only 1.8 thousand, vertices 2.9 thousand. They haven't changed. Okay, use textures is exactly the same, render textures is exactly the same. Alright, so it doesn't do anything there. It basically just speeds up the process between the CPU and the GPU. Our CPU, you'll notice that our rendering looks like it's got a lot bigger, but as soon as I put others on, oh, it has actually, the rendering has got a lot bigger, and that's probably because it's all batched. Okay. Oh, actually, no, it hasn't. Look, so as soon as I switch off others, it's gone right back down to where it was originally. All right, it was basically just zoomed in because I had the others switched off. Okay, so no change to the rendering on the CPU, massive change to the draw calls. So that is a really key tip for when working with mobiles.